This is the Smart Buildings Academy podcast with Phil Zito, episode 212. Hey folks, Phil Zito here, and welcome to episode 212 of the Smart Buildings Academy podcast. In this episode, we are going to be going through IT Networking 101. So after last week's episode on IP controllers, I got a couple messages that folks were asking me, hey, some of the terms you used in that podcast didn't make sense to me. I really don't understand how messages flow on the network. You talked about subnets and VLANs and network flow. How does all that work? So in this episode, we are going to be looking at the journey of a couple messages. We're going to look at BAS IP controllers communicating to supervisory devices. We're going to talk about web messaging from a user interface like a Google Chrome or Internet Explorer to a BAS server. And maybe, depending on time, we'll look at a couple more. Everything that is covered in this episode can be found at podcast.smartbuildingsacademy.com/212. Once again, that is podcast.smartbuildingsacademy.com/212. All right, so with that being said, let's dive into this episode. And if after this episode you really still are struggling to understand a lot of these concepts, I'd encourage you to check out our IT for Bas Professionals course, and you can find that in the show notes page. All right, so whenever we're talking about IP communication, which is primarily what we're focused on in this episode, we are thinking of layers. Now, there's this thing called the Osi Model, which is a 7-layer model and talks about messaging across different layers. I'll provide a link to an article we wrote on the Osi Model in the show notes page. But I like to refer to the Osi Model whenever I'm teaching people networking because it provides a visual model that explains the flow of data. So if we think about our IP controller and it needing to send data to a supervisory device, maybe it's trying to populate data in a shadow object on a supervisory device, or maybe there was a COV message that requested data from the controller and it needs to update it. Well, in this case, the IP controller, the first thing it needs to do, right, is it needs to figure out where it's sending the message to. So typically, it's going to send the message to an IP address. If it's an IP controller and it's using IP, it's going to send the message to an IP address. So it's going to form what's called a packet. And so you're going to notice, right, we're going to start at layer 3, we're going to work down to layer 1, and then we're going to work up to layer 4, and I'll describe what these layers are as we move through the episode. But it's going to start by forming a packet, and a packet is a layer 3 message type. So at each layer, layer 2, layer 3, layer 4, you have different message types. Layer 2, you have Ethernet frames. Layer 3, you have IP packets. And layer 4, depending on whether you're using TCP or UDP, you have segments. So layer 3, we form a packet, okay? And this packet is going to go out a specific port. It's going to go out a logical port. At layer 4, that's typically going to be UDP 47808. So this traffic is going to originate out of a actual port. It's going to have a destination IP address that's going to be in the actual packet. And that packet is going to get encapsulated in an Ethernet frame. So there's this concept called encapsulation and decapsulation. And basically, the way a lot of folks like to explain it is this envelope concept, which is you have an envelope, and inside that envelope, right, is going to be some messaging and some data. So what tends to happen is you have Ethernet frames that they get decapsulated, meaning you take the message out of them, and inside, lo and behold, there's an IP message. So what happens, right, is the IP controller forms this message. It forms this message, and it sends it out, and it says, hey, I'm trying to reach this IP address. It reaches the switch. The switch actually goes and looks for the IP address. If it's on that subnet, great, it decapsulates it, and it goes and actually sends the Ethernet frame to wherever it's got to go, right? So decapsulation and encapsulation. If it does not know where to send that message to, then what it's going to actually go and do is it's going to send that IP message to what's called a default gateway. And that's at a router. So I'm sure you've had to enter default gateways. Whenever we ask for IP addresses as part of working with IT, we tend to go and say, hey, can you give me the IP address, the default gateway, and the broadcast mask? Because at the end of the day, for our local area networks and for our devices on our local area networks, those are the pieces of information we need to give a unique identifier to our controllers, to our supervisory devices, so that they can communicate. Now, the thing with IP addressing is we have this concept called subnets. And I know it's going to feel a lot like I'm bouncing around from topic to topic to topic, and it's going to feel a little unstructured, and that's by design. So just if you feel that way as we go through this episode, don't worry, that's by design. So as I mentioned, right, the IP address is going up to the router to this default gateway. Because here's the deal. You have this thing called a subnet. Well, what happens with IP addressing is we have a limited number of IP addresses in the world, public IP addresses, that is, IP addresses that are routable across the internet from network to network. Now, in order to overcome that, we have what are called private IP addresses. These are private classes of IP addresses that are not public, that can be reused again and again and again on different networks. So if you've heard 192.168.1.0/24, that is a part of the Class C private range of addresses. Why does this matter to you? It matters to you because you have this subnet, and within this subnet, the devices can communicate to one another. But if you have an address on 192.168.2.0/24, that is a different subnet. Now, I'm not going to try to teach you subnetting in this episode. That's more of a visual concept, so it'd be very difficult to teach you. That being said, subnets cannot communicate to one another unless there are routes. So you send your message, the router or the switch actually sends your message to the router and to the router's default gateway. The default gateway is where traffic goes by default if it's not in the subnet that the switch is handling. So you send that IP address to the default gateway, and the default gateway looks at its routing table and says, oh, I know how to get to that. We're going to go out physical port serial network 1-0-1. And so it sends its traffic out. Traffic ends up at another router. That router looks at its routing table and says, oh, yeah, subnet 192.168.2.0, yeah, you go out fast Ethernet port, whatever. And that then broadcasts that message, or unicasts that message. That's very important that I said unicast and not broadcast, because unicast, broadcast, and multicast are totally different things, and we'll talk through that in just a second. But it unicasts that message from the router to the switch. Now, the switch, we didn't cover this earlier, but the switch has this thing called an ARP table, an Address Resolution Protocol table. And this table routinely updates through ARP messages. And basically what it does is it looks at the switch and all the devices that are plugged into its ports. And it builds this table saying, oh, on Ethernet port 1, that is MAC address whatever, IP address whatever. And so now that switch says, oh, you want to get to 192.168.2.10? Well, that's on fast Ethernet 4, whatever, right? Port 4. And then it looks at the Ethernet address and it sends an Ethernet message to that device, and that device receives it. The network interface card receives it, and data flows through, right? Because the Ethernet message is encapsulating the IP message, and it's encapsulating, right? It's encapsulating that TCP message. So that's how all this works. You have encapsulation and you have decapsulation. Now, with all of that being said, so you've got all this wonderful stuff, encapsulation versus decapsulation. The important thing to know in regards to that is that this happens at multiple different points. It's not once, right? So let's say you send a message, an Ethernet frame, right? And you send that Ethernet frame to, you send it to the switch. So from, let's say, BAS controller, right, to the switch, okay? And then when it gets to the switch, right, it gets encapsulated. And sometimes it gets encapsulated at the actual host device. But it gets encapsulated at either the switch or at the host device, depending on what you're doing. And then it gets decapsulated. And this happens multiple times. And so this is something when folks are actually troubleshooting networks and they're trying to read the networks and they see on like one subnet that there's this source and destination and this to and from Ethernet message. But then on a different subnet, they're different. That's why, because the message structure is going to change as the message flows through the network. Now, the important point to realize here is that we have several things going on, right? We have our physical layer, and that's just simply purely the ones and zeros signaling, the cable, the physical port that the systems are connected to. And there should never, well, I don't want to say never. There should be very little troubleshooting you're doing on this. Any troubleshooting is usually due to issues with wiring, improper termination of RJ45 heads on your Cat 6 or Cat 7 cabling. And so those are kind of the issues you're going to find there. Layer 2, the main concern you're going to have with layer 2 is that you are actually connected to the switch and that the switch is set up properly. So the issues you're going to run out into layer 2 are going to be issues with MAC address, port security, things like that. And then layer 3, you're going to run into routing issues, IP addressing issues, making sure you're on the right subnet, making sure you can reach the right subnet. And layer 4, you're going to run into things with like UDP ports, making sure that everything's set to port 47808 so they can communicate properly across BACnet, right? Because BACnet's what we usually use. Now, when we move to an actual web message to a BAS server, and from a BAS server to a web message, our structure actually changes. Because now what we're using the full stack. So prior to this, right, prior to the web message to BAS server, in that example of BAS IP controller to supervisory device, we're really just using layers 1 through layers 4. We're using the physical layer, the data link layer, the IP networking layer, and the transport layer. Now we are starting to use things like the session layer, layer 5, the presentation layer, and then the application layer. So when we start to use those additional layers, we're going to have things that happen that we need to go and realize why they're happening, because it's going to affect our ability for us to be able to access the web application and be able to troubleshoot the web application if we're not able to do it. So pretty much like what happened before, your computer that you are using to connect to the BAS server via like Google Chrome, what's going to actually happen is you're going to work down the stack from layer 7 to layer 1. The message is then going to come out of your host, out of your network interface card on your laptop or computer. It's going to travel to the switch, which is going to determine, hey, the server's on this same subnet. I can send messages to it. Or it's not on the same subnet. I need to send it to the default gateway, and then the default gateway is going to send it to another router via the routing table down to the switch on the other subnet to the BAS server. Now, all of that, was pretty straightforward, explained in the previous example. And you may be like, well, it wasn't very straightforward because you bounced around a lot. And I get that, and I understand, because these are largely visual topics. If this was something you could see, it'd probably be a little bit easier to understand. It's something that's a little bit difficult to understand from an auditory perspective. But that being said, if you just listen to this again, the logical flow of from the network interface card to the switch via Ethernet gets decapsulated, form to an IP packet sent to the router. Router sends that IP packet across the network, across its trunk link from router to router, then back down to the switch where it gets re-encapsulated into an Ethernet message so it can be sent out the port to the server. And that's how that network traffic works. But at the higher levels, at the actual higher levels of the OSI model, where we are looking at the session layer, and the session layer is going to be very important because when you're using web browsing to actually open up your BAS to web view through the graphical user interface of Chrome or Mozilla Firefox, whatever, what you're actually doing is you're establishing a TCP connection. You're establishing a session, especially if you're using HTTP or HTTPS. You're establishing a connection between the BAS server and your web user interface. And what's going to happen is after that session layer, you're going to have the presentation layer. And the presentation layer is going to detail out the syntax of the message. So how is the message sent? How is it encrypted? How is it compressed? So this is basically going to handle how the actual data flows and is presented across to the server or to the web browser. If you've ever went and opened up your BAS in like Chrome and hit F12 and went into developer mode, you have likely seen the HTML, the CSS, and the JavaScript that is actually being sent across the network and is being rendered in HTML files. So all of this is going to be supported at layer 7. This is the application layer. This is where your HTTP application is going to take place. That's Hypertext Transport Protocol. That's essentially the language of web servers and web pages. That's where all of that's going to take place. So what's actually happening, and this is what a lot of folks don't understand, and this is really important because I know at this point some of you may be like, man, this is really technically deep. But this is really important because what a lot of folks don't realize is that they are not troubleshooting BACnet IP messages between their user interface and their server. Typically, what they're usually troubleshooting are HTTP post, get, put, and delete messages. So these are some of the primitive actions of the HTTP protocol. So when you go to get data from a BAS server, what you're actually doing is you are doing a GET request against a resource on that server. So what you often are doing is like you want to get the status of zone temp. You are often communicating to that server and saying get zone temp status, and then it is getting a zone temp status. And if you are updating a zone temp set point, you're doing a post. You are posting data to that endpoint. And so once you start to understand this, and I know it's a little bit more difficult to troubleshoot these days because a lot of BAS systems are using HTTPS and they're using like TLS, and that's basically a form of an encrypted service. And that makes it difficult to troubleshoot and read those messages. But that being said, in developer mode, you can view those messages actually in the web browser. Now, with all that being said, if you understand put, delete, post, and get, which really most of the time you're just going to be using post and get, if you understand those, then you can start to actually understand how the message exchanges between the BAS server and your user interface. And that's going to be critically important because when, like I said, you're troubleshooting and you're not able to communicate, it's either something with the web server at the HTTP layer, or it's something usually at the transport layer. It's got something to do with like an access control list that is blocking a port, a logical port. It's blocking maybe HTTP, or sorry, maybe it's blocking like I guess we could say HTTP. That could be something that's being blocked. You could, if you're using like Fox service or something to exchange, that could be being blocked. You have multiple different ports and services that you need to have in order to communicate between your web browser and your actual web server. And so that's an area where things can go wrong. Now, here's the good thing. Here's the good news about all of this, as confusing as it may be, is that if you understand what I talked through earlier about basic BAS IP controller networking to supervisory device, layer 1 through layer 4, the steps you're going to take to troubleshoot those problems are going to be exactly the same across pretty much every single device. You're going to troubleshoot layer 1, layer 2, layer 3, and layer 4 pretty much exactly the same. It's only when you get to layers 5, 6, and 7 that your troubleshooting gets a little bit different based on the protocol, based on the presentation syntax, and based on session management. So that is going to be the variable piece. But the good news is that if you understand layers 1 through 4, then you'll be able to troubleshoot, which in my opinion is like 80% of the issues you run into, right? An IP address is not in a routing table, or a port's being blocked in an ACL, or at a switch you have MAC addresses being limited at the port, and so the port's disabled. Those are all really common occurrences. It's very rare that you have an issue with syntax of the actual presentation layer, or that you have like a major issue with doing a post to the web server. It's very rare that that stuff doesn't work. That stuff is actually pretty stable. It's the lower layers where we tend to run into our issues. So I know this was a little bit deeper. That's why I'm actually making it a shorter episode than our normal 30-minute episodes, because I just basically did a Vulcan mind meld with you for about 20 minutes and did a mental dump of IT network topologies and network processes and flows, and talk through some parts and pieces. So I'm just going to recap real quick on a couple parts and pieces, and then we'll end the episode. So just remember that at the physical layer at your machines, you have network interface cards. And these network interface cards have typically Ethernet cables that connect to them using RJ45 heads. And those Ethernet cables connect between your host device and its network interface card and the switch using what's called an access link, because it accesses the network using that link. That's a typical patch cable type A or type B wiring. At the switch, that is a layer 2 device. It exists to switch data between ports. I'm not really going to get into VLANs and setting up VLANs per ports and how switches support VLAN trunking and can actually support multiple subnets. So when I tell you that a switch typically supports a single subnet, don't start sending me emails going, switches support VLANs across multiple ports, and they support VLAN trunking across the trunks, so they can actually have multiple VLANs across a port. I get that. Completely agree, but we're talking basics here, and I don't want to confuse people with that. Your typical unmanaged switch, which is what most of us use out in the field, not a managed switch where we can do that with VLANs per port, but our typical unmanaged switch supports a single subnet across maybe 8 or 16 ports on it. Now, from that switch, we have what is called a trunking port. And that trunking port, once again, most likely using Ethernet cable, goes from the switch to the router. Now, the router is a layer 3 device, meaning it's primarily focused on IP networking. And that layer 3 device is going to use routes and routing tables to be able to go and say, hey, this is the port, the physical port I send my traffic out of to go and reach another network. Now, once again, we have stuff at the transport layer, and that's UDP or TCP, and that's all about data flow. UDP being connectionless, meaning it just sends the message and doesn't wait for acknowledgement. TCP being connection-oriented, meaning it sends a message and waits for acknowledgement. For most of your web browser traffic, you're going to be using TCP because you're going to want to confirm that the message was received. For most of your like backnet field controller stuff, stuff, BACnet IP, you're going to be using UDP messages. So I hope that hearing this made you more familiar with the terms. I realize there's not a visual component to this podcast. If you are still feeling very uncomfortable, I would really encourage you to check out our IT for Bas Professionals course. It's a long one. It's like 30 hours long, but it really, really, really grounds everything you need to know about IT from a BAS perspective. That's the real benefit of that course, is it's not just focused on teaching you Network Plus or CompTIA, A plus certified, whatever. It is actually teaching you what you need to know as a BAS professional from a BAS angle. And then in each module, we spend time talking about how to deal with IT objections, how to explain why you need IP addresses, why you need virtual servers, why you need a database, etc. So I think you'll really enjoy that course. And like I said, it can be found at podcast.smartbuildingsacademy/212. That being said, thanks so much for listening to the podcast. As always, I encourage you to leave your questions. I look forward to hearing from you and hearing your thoughts and talking to you again next week. Thanks a ton and take care. Thanks a ton.